All right, good evening, ladies and gentlemen. Hey, I'm at home and I'm going to do a screencast to help you study for your biology ecology test. I'm going to talk as fast as I can. I'm going to make two screencasts. Each one will be about 10 minutes long, and that won't be enough time to review everything that you need to know for this test. I would say most of you need to study a minimum of 1 hour to pass this class. And if you're pass this test, and if you're looking for a really good grade, you need to be studying more than that. Try the Moodle Quizlet, use the flashcards, and listen to this and look at your study guide. I am going to go over the study guide. You can see I have a split screen here. I opened 5 sets of notes over on the left side of the screen. Those notes are all available on Moodle under ecology. It's called all notes here or something like that. I don't know. And you can reference back to those notes at any time, but I'll go back and forth a little bit just so you can see where they are. Okay, I'm going to start at the top of your ecology review packet and just go back and forth between the notes and the review packet. Things that I really want you to know from our review packet. First of all, healthier and better educated populations have lower birth rates. Absolutely true. Every time in the world when populations have gotten more education and have gotten good healthcare, their birth rates drop. That has to do with them being able to plan for the future, stay in school, get better jobs, start businesses, all kinds of things. You just have to trust me. Healthier and better educated, fewer babies born. Crazy idea. Okay, I'm going to scroll down a little bit. Let's try number 5. How are cows and other ruminants impacting global warming? Hopefully, you remember the two main global warming gases. Number 1 is carbon dioxide, and that's from burning fossil fuels. And we get that when our factories are burning fossil fuels. Every time we drive a car or run a laptop, we're burning fossil fuels, unless we're getting those sources from wind, geothermal, solar power, that kind of thing. And carbon dioxide is a global warming gas. But cows, going back to number 5, they fart a chemical called methane, and that is a much worse global warming gas than carbon dioxide is. And so cows have a huge impact actually on global warming. It's a crazy idea. All right, I think I'm a couple things here. What is the biggest driver of deforestation? Agriculture. That's the number one reason we're cutting down our trees, is to make farms. And then the ozone layer is the layer in the atmosphere that protects all life on this planet, basically from cancer, from skin cancer. And without the ozone layer, then ultraviolet radiation reaches us and animals and plants. Everybody needs to be protected from the sun's ultraviolet radiation. We released chemicals into the air called CFCs, and those damaged the ozone layer. We made it illegal, and the ozone layer has gotten much, much better. Just a few years ago, though, they did notice that CFCs are increasing again. Not important. Just saying that it's caused by CFCs, and we know how to take care of it. And it has nothing to do with global warming. The depletion of the ozone layer, not related to global warming. Global warming is about carbon dioxide, methane, and other global warming gases. CFCs are not global warming gases. Okay, totally changing subjects. Let's talk about the symbiotic relationships. That's from over here in this biological community interactions notes. You actually did an activity in class where you learned about competition, predation. We talked about plus minus zero, and we talked about how with competition, it's always minus minus. They compete with each other. It's always bad. Interspecific competition is different species. Intra-specific competition is members of the same species, and it's always bad for them. We talked about predation being plus minus. The predator benefits. The animal getting eaten is harmed. We talked about, give me a second. Oops, I thought we'd get faster than that. There we go. Parasitism is also a plus minus. The parasite benefits, like a tick or a flea or a worm, an intestinal worm, they're eating us and they're getting food, so that's a benefit. It harms us. It harms us slowly, so that's a minus for us. The next one that we talked about was mutualism. Mutually beneficial, plus plus, they're helping each other. So the idea of, for example, butterflies pollinating flowers. Flowers give butterflies food. Butterflies pollinate the flowers so that the flowers can reproduce. Those are examples of mutualism. And then the last one we talked about is a word nobody is familiar with when they come into my class, and that's the word commensalism. That's a plus zero. That's an example where one animal is benefiting and the other animal is unaffected. All right, I'm going to scoot on to the next section, the ecosystem cycling, and I'll switch a set of notes here. The process of the water cycle, that's something you should have learned in elementary school. But one word that most of you hadn't heard before was the word transpiration. Transpiration is the release of water from plants, the evaporation of water from plants. And it actually is part of why rainforests rain so much. There's so many plants, they cause so much evaporation, they form clouds, and then it rains. You cut down the rainforests, and it stops raining. Crazy idea. All right, we talked about in this set of notes, we talked about the phosphorus cycle. And the phosphorus cycle, the only thing I needed you to know about the phosphorus cycle was the involvement of fertilizer. Fertilizers wash into our lakes, phosphorus fertilizers wash into our lakes, and they cause plants to grow that don't belong there. Then the fertilizer runs out, and then that leads to the fish dying. It's a whole long story, but that process is called eutrophication. And here's that word right here, eutrophication. Eutrophication, I try to help students remember, eutrophication is the phosphorus cycle. It's caused by fertilizers washing in the lakes, and it leads to fish deaths. One more time, eutrophication, phosphorus cycle, fertilizers, fish deaths. Trying to help you remember it. All right, the next cycle that's on this list here is the nitrogen cycle. Let me see if I can find the nitrogen cycle. Where is it? The one thing that I need you to know about the nitrogen cycle is the involvement of bacteria. So nitrogen is in the sky, and we desperately need nitrogen. The only thing that can access the nitrogen that's in our atmosphere are bacteria that live in the roots of legumes. Legumes are plants like peas and beans and peanuts. They take the nitrogen out of the sky and feed it to the plant, and then we eat that plant, or we eat an animal that ate that plant, and that's how we get the nitrogen. When we decompose, then there are bacteria that return our nitrogen back into the sky, so that it's a whole cycle. You need to understand legumes, and you need to understand bacteria are part of that cycle. All right, and then the last cycle that we talked about is the carbon cycle. And this is a great diagram of the carbon cycle, and I drew it over here as well. The part of the carbon cycle, that's the two parts of the carbon cycle that are really out of balance right now: too many emissions, too much combustion, which is burning anything, adding carbon dioxide to the sky. Carbon dioxide, that's why it's part of the carbon cycle. During photosynthesis, plants are supposed to remove carbon dioxide from the sky. So they should be filtering our air and cleaning it up, and it should be no big deal. However, we are cutting down our trees. And worse, we're burning some of our trees, which anytime you combust, there's that word, anytime you combust anything, you return carbon back into the sky. Too much of this, not enough of this. Now the carbon dioxide is in the sky, and it's leading to global warming. It also leads to ocean acidification as it mixes with the water. Okay, I think that's it for that set of notes. So I'm going to scoot on. This is a set of notes that we didn't actually talk about in class, but I'm just going to zip through some things. You did a packet on this instead of having me lecture on it. So producers is the 7th grade word. Autotrophs is the high school level word. Basically, it's the idea of any organism that can make its own food. So those would be organisms that can photosynthesize. Typically, those are plants. It might be algae in an aquatic ecosystem. And then the opposite of that would be the consumers and the heterotrophs. Consumers, 7th grade word, heterotroph, 10th grade word. They obtain their energy by eating, and they include the herbivores, carnivores, and omnivores. One of the questions I ask you on the test is, who could we support the most people on this planet if we were herbivores, carnivores, or omnivores? And the answer is herbivores, and we'll get to that in just a second, why that would be. All right, so if I skip down to this image here, whoops, that should be good. Let's see, trying to make sure I cover everything that I think is super important. Is there another one right here? Energy flows from producers to consumers. I only have about 30 seconds left, you guys, so I think I'm going to have to stop this one, but stop this screencast. I got a warning that I'm almost time's up. But if you notice on a food pyramid, The largest number of organisms are the producers down at the bottom, and then there's only 10% after that and 10% after that. That's because heat is lost at every level, and so there's less and less energy available to each level. So the animals that are up at the top, there's very, very few of them.